In this video, we want to look at some example problems using the coefficient of friction and the force of friction as we solve for both static and kinetic friction in various problems. We'll start here with a pretty basic problem, and then we'll increase the level of difficulty as we go through. With each of these problems, I highly recommend that you pause the video, try the problem yourself, and then press play again to watch my answer. A hockey puck has a coefficient of kinetic friction of 0.10. If the puck feels a normal force of 5 newtons, what is the frictional force that acts on the puck? So in this case, we are given information. Mu sub k is 0.10. Remember, there are no units on coefficient of friction. Force normal is 5 newtons. We're looking for force friction. The equation we have to work with for friction is the force of friction. In this case, kinetic is the coefficient of kinetic friction times the normal force. So in this case, the force of friction kinetic is 0.10 times 5. So our force of friction, which will be kinetic, sliding across the surface, is 0.5 newtons. It's pretty basic, just plug into the equation type problem. This next problem, suppose a 10 Newton force is applied to the side of a 4 kilogram block that is sitting on the table. The table has a coefficient of friction that is 0.20. What is the acceleration of the block? So our variables here, we have a normal force or an applied force being pushed on the block. We have a mass of the block of 4.0 kilograms. We have a coefficient of kinetic friction because it's going to slide, 0.20. We are looking for acceleration. Here we have multiple forces that we're going to pay attention to. So let's draw a free body diagram for what is taking place here. There are 4 forces: force of gravity, force normal of the ground pushing up, or the table, force normal being applied, and we know force friction kinetic will be going the other direction. We know that F net equals ma from Newton's second law. So we need to be able to get all of the forces added together. We know this will not be accelerating up or down. It's going to be sliding across the table. So we know gravity and normal force will cancel each other out. I'm going to make to the right positive. So I know that the normal force plus the frictional force will equal 4 times A. But I need to know those values before I can move forward. I do know the value for this one. This is going to be 10 newtons. But I have to know what the frictional force is going to be able to solve for the acceleration. So to do that, I need to start labeling these forces. The easiest force for me to figure out is force of gravity. Force of gravity is the mass, 4, times acceleration due to gravity, 9.81. So we get 39.24 newtons. So we know this one has to be 39.24. Because of that, and the fact that this is not accelerating vertically, we know that the normal force going up has to be 39.24. We know frictional force is the coefficient times the normal force. So now that we know the normal force, we can solve for the frictional force. 0.20 times 39.24, which comes out to 7.85 newtons. So the frictional force is 7.85 newtons, and it's going to the left, so it needs to be negative. So 10 plus negative 7.85 equals 4A. So 10 minus 7.85, 2.15 equals 4A. A will be 2.15 divided by 4, which comes out to 0.54 meters per second squared. It's going positive because it's going to the right, because there's more force to the right than to the left. Okay, if we take the same block as in the previous problem, what would be the minimum value of the coefficient of static friction in order for the block to remain motionless? So, we still know that the mass of the block is 4.0 newtons. The force normal that's being applied is 10 newtons, and we're going to make this to the right. We know that the acceleration now will be 0 meters per second squared, and we're looking for the coefficient of static friction. We have the same free body diagram, except now it's not moving, so this force normal and this force friction static, we know a couple of things. We know this is 39.24. We solved that in the previous version of the problem. We know this is 10. So the up and down forces cancel out. F net equals ma. So 10 plus the force of friction static equals 4 times 0. Anything times 0 is 0, so the force of friction static has to be negative 10 newtons in this case. If they're going to cancel each other out, they have to be the same value in the opposite direction. So the force of friction static equals the coefficient of static friction times the normal force. So 10, the negative just tells us direction. Coefficient is what we're trying to solve for. And this normal force is 39.24. So the coefficient of static friction will be 10 divided by 39.24, which is 0.25 as the coefficient of friction. So a slightly larger value will now keep the object from moving. A block weighing 300 newtons is moved at a constant speed over a horizontal surface by a force of 50 newtons parallel to the surface. What is the coefficient of kinetic friction? So in this case, I know the force of gravity is 300 newtons. I know the applied force is 50 newtons. I'm looking for the coefficient of kinetic friction. My free body diagram here will have four forces again: gravity, normal, applied, and force of friction kinetic. I know F net equals ma, so F net, oh, one other piece over here, I forgot to write down. Acceleration is 0 meters per second squared. Equals the mass times 0. So regardless of what the mass is, we could figure out the mass, but it's not going to matter because we know the net force will be 0. So all four of these forces have to cancel out. I know this force is 300. I know this force, therefore, is 300 going up. I know this force is 50, which means this force must be 50 in the other direction. So force friction kinetic is the coefficient of kinetic friction times the normal force. So 50 equals the coefficient of kinetic friction times 300. So the coefficient will be 50 divided by 300, which would be 0.167. Okay, here's another problem. 100 Newton force is applied to the side of a crate resting on a level floor. The crate has a mass of 50 kilograms. The coefficient of static friction is 0.25. Is the 100 Newton force enough to make the crate accelerate? So, let's draw our free body diagram again. Force gravity, force normal, force applied, and force friction static. If the force friction static is different than the force applied, the object will accelerate. We know the normal and gravity will be the same. So we need to figure out what the force friction static is, because we know that this will be 100 newtons. We do not have the value of any of these other forces. So force of gravity equals mass times acceleration due to gravity. Force of gravity equals 50 times 9.81. This comes out to 490.5. So this force has to be 490.5. This force has to be 490.5. So now we got to find the frictional force. Force of friction static. It's the coefficient of static friction times the normal force. So the force of friction static is 0.25 times 490.5. Comes out to 122.6 newtons. Now in this case, that means that the static friction force here can be as much as 122.6 newtons. That does not mean that the force has to be that amount. If you only apply a 100 newton force, the static friction force would stay at 100 newtons and the object wouldn't move. Static friction, you have to get greater than the static friction force for the object to accelerate. So the answer in this case is no. So those are a number of examples of friction force problems. We'll continue to do a number of these with the online homework and in class, so please bring any questions and a copy of your notes to class with you tomorrow.